P-leads, also known as protective leads, are employed in hazardous Class 1 Division 1 locations specifically when a motor lacks an integral terminal box. The usage also extends to instances where the existing integral terminal box proves unsuitable for the application's demands, such as when the motor operates in environments susceptible to corrosive gases or liquids. Standard P-leads typically measure around 18 inches in length and are constructed from materials exhibiting resistance to the hazardous conditions, such as stainless steel or copper-nickel alloys. These leads connect directly to the motor's terminals and extend to a safer, more accessible location where they interface with the wiring system. The implementation of P-leads offers a secure and reliable method for connecting the motor to the wiring system within hazardous locations. Furthermore, they play a crucial role in safeguarding the motor from the surrounding hazardous environment. When working with P-leads, it is important to follow a series of steps to ensure proper installation and functionality. Firstly, identify the motor's P-leads, typically distinguished by a tag or label affixed to them. Secondly, securely connect the P-leads to the motor's terminals, ensuring that all connections are tight and that no bare wire remains exposed. Thirdly, carefully extend the P-leads to a suitable location where they can be connected to the wiring system, ensuring that the chosen location provides both accessibility and safety. Fourthly, secure the P-leads to the wiring system, verifying that all connections are secure and that no bare wire remains exposed. By adhering to these steps, electrical professionals can effectively utilize P-leads to ensure safe and reliable motor operation in hazardous environments. The importance of proper installation and maintenance cannot be overstated, as any compromise in these areas could lead to electrical hazards and potential equipment failure. Class 1 Division 1 locations are defined as areas where ignitable concentrations of flammable gases, vapors, or liquids are present continuously, intermittently, or periodically under normal operating conditions. These locations require specialized equipment and wiring methods to prevent explosions and fires. Motors used in these areas must be explosion-proof and must be installed in accordance with the National Electrical Code, specifically Article 501. P-leads provide a critical link between the motor and the wiring system, ensuring that the motor's internal components are isolated from the hazardous environment. Without P-leads, the motor's terminals could be exposed to flammable substances, creating a significant explosion risk. The choice of material for P-leads is also crucial. Stainless steel and copper-nickel alloys are commonly used because they are resistant to corrosion and degradation in harsh environments. The length of the P-leads is also important. 18 inches is a typical length, but the actual length may vary depending on the specific application. The P-leads must be long enough to reach a safe location where they can be connected to the wiring system, but they should not be so long that they become a tripping hazard. When connecting P-leads to the motor's terminals, it is important to use the correct connectors and to torque the connections properly. Loose connections can cause arcing and sparking, which can ignite flammable substances. It is also important to ensure that the P-leads are properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect personnel and equipment from electrical shock. The wiring system that connects to the P-leads must also be suitable for use in hazardous locations. This typically means using rigid metal conduit or explosion-proof cable. The conduit or cable must be properly sealed to prevent flammable substances from entering the wiring system. When installing P-leads, it is important to follow all applicable codes and standards, including the National Electrical Code and any local regulations. It is also important to consult with a qualified electrical engineer or inspector to ensure that the installation is safe and compliant. Regular inspection and maintenance of P-leads are essential to ensure their continued functionality. P-leads should be inspected for signs of damage or corrosion. Any damaged or corroded P-leads should be replaced immediately. The connections to the motor's terminals and the wiring system should also be inspected to ensure that they are tight and secure. In addition to visual inspections, it is also important to perform electrical tests on the P-leads to ensure that they are properly grounded and that there are no short or open circuits. These tests should be performed by a qualified electrician using calibrated test equipment. The NEC provides detailed requirements for the installation and maintenance of electrical equipment in hazardous locations. Article 500 defines hazardous locations and classifies them into different classes and divisions based on the type of hazard present and the likelihood of it being present. Article 501 covers the specific requirements for Class 1 locations. This article specifies the types of wiring methods, equipment, and installation practices that are permitted in Class 1 Division 1 and Division 2 locations. It also provides guidance on the selection of explosion-proof equipment and the proper sealing of conduits and cable enters. The NEC also contains requirements for grounding and bonding of electrical equipment in hazardous locations. Proper grounding and bonding are essential for preventing the buildup of static electricity and for providing a path for fault current to flow back to the source. The use of P-leads is just one aspect of electrical safety in hazardous locations. It is important to have a comprehensive understanding of all applicable codes and standards and to follow safe work practices to prevent explosions and fires. In addition to the NEC, there are other standards and guidelines that may be applicable to electrical installations in hazardous locations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, the International Society of Automation, and the National Fire Protection Association. It is important to be familiar with all applicable standards and guidelines and to follow them carefully. Training is also essential for electrical workers who work in hazardous locations. Workers should be trained on the hazards present in these locations, the proper use of electrical equipment, and safe work practices. Training should be provided by qualified instructors and should be updated regularly. Furthermore, it is important to remember that electrical safety is a shared responsibility. Everyone who works in or around hazardous locations has a responsibility to be aware of the hazards and to follow safe work practices. By working together, we can prevent explosions and fires and create a safer working environment. Remember to always energize electrical circuits before working on them. Use lockout/tagout procedures to prevent accidental energization. Wear appropriate personal protective equipment such as safety glasses, gloves, and hearing protection. Be aware of your surroundings and watch out for potential hazards. Report any unsafe conditions to your supervisor. By following these simple safety tips, you can help to prevent electrical accidents and injuries. When selecting P-leads, it's essential to consider the specific hazardous environment in which they will be used. Factors such as the type of flammable substance present, the temperature range, and the presence of corrosive chemicals should all be taken into account. Different materials and constructions are available for P-leads, each offering varying degrees of resistance to these factors. For instance, in environments with high concentrations of corrosive chemicals, P-leads made from stainless steel or other corrosion-resistant alloys would be the preferred choice. Similarly, in high-temperature environments, P-leads with high-temperature insulation should be used to prevent degradation of the insulation material. The selection of the appropriate P-lead material and construction is critical for ensuring the long-term reliability and safety of the electrical system. Additionally, the installation of P-leads should be performed by qualified and experienced electricians who are familiar with the requirements for hazardous locations. Proper installation techniques are essential for maintaining the integrity of the explosion-proof enclosure and preventing the ingress of flammable substances. This includes ensuring that all connections are properly torqued, the sealing fittings are installed correctly, and that the P-leads are properly supported to prevent stress on the connections. Furthermore, the routing of P-leads should be carefully planned to minimize the risk of damage or abrasion. P-leads should be protected from sharp edges, excessive bending, and exposure to mechanical stress. In some cases, it may be necessary to use conduit or other protective measures to safeguard the P-leads from physical damage. Regular inspection and maintenance of P-leads are crucial for identifying and addressing any potential problems before they can lead to a hazardous situation. Inspections should include a visual examination of the P-leads for signs of damage, corrosion, or deterioration. Connections should be checked for tightness and security, and any loose or corroded connections should be repaired or replaced. Electrical tests, such as insulation resistance tests, should also be performed to verify the integrity of the P-lead installation. Any P-leads that fail these tests should be replaced immediately. It's also important to keep accurate records of all inspections and maintenance activities. These records can be used to track the performance of P-leads over time and to identify any trends or patterns that may indicate a potential problem. Proper documentation is also essential for demonstrating compliance with applicable codes and standards. In addition to the technical aspects of P-lead selection, installation, and maintenance, it's also important to consider the human factors involved. Workers who are involved in the installation and maintenance of P-leads should be properly trained and qualified to perform these tasks. They should also be provided with the necessary tools and equipment to do their job safely and effectively. Furthermore, it's important to foster a safety culture that encourages workers to report any unsafe conditions or practices. By creating a safe and supportive work environment, you can help to prevent accidents and injuries. The use of P-leads in hazardous locations is a critical aspect of electrical safety. By following the guidelines and recommendations outlined in this narration, you can help to ensure the safe and reliable operation of electrical equipment in hazardous environments. Remember to always prioritize safety and to consult with qualified professionals when necessary.